we're going to talk about an addition, an approach to adding two vectors geometrically, and an approach to subtracting two vectors geometrically. We've already defined the addition of two vectors with algebra. That is, if v is a vector AB and u is a vector CD, then the definition, then v plus u, we add these vectors together, it results in another vector that is equal to a plus c and b plus d. So basically what you add is the first coordinates a and c, and you add the second coordinates b and d together. So what does this look like graphically? Well, I'll try to draw a picture of this. And let's do an example. So let A equal the vector 2, 1, and B be the vector 3, 1. And I want to show the vector sum A plus B. Now I can calculate it by this definition. A plus B must be the first coordinates added together, 2 and 3. I wanted to make this 1, 1, 2. Let's make that 1 and 2. Okay. First coordinates together, 1 and 3, which is 4. Let me write it out. 1 plus 3. And we add the second coordinates together, 2 plus 1, which 1 plus 3 is equal to 4, and 2 plus 1 is equal to 3. So the resulting vector, when you add them together, is 4 in the x direction, 3 in the y direction. So let's draw the picture of this graphically, see what's going on. Scoot this to the right. Okay. 1, 2, 3, 4. 1, 2, 3, 4. Let's do that. Okay, so the first thing I'm going to do is I'll draw A in red, B in green, and the result, A plus B in blue. So when I draw A, that's a vector 1 in the x, 2 in the y. So the tail of the vector, if I make the initial point, the origin is at 1, 2. So that's vector A. If I draw vector B, that, again, if I make its origin at 0, 0, then it will go 3 in the x and 1 in the y. So this is my vector B. What then does the vector A plus B look like, given the Well, A plus B is 4 in the x and 3 in the y, so it would be up here. And how could I get to this vector? How could I get to this point here? Well, if I travel along A, and then I go from this endpoint here, a distance, a vector B, so I go to this point, and then I take this vector and just slide it up here. I can get to my sum vector, A plus B. So if I go to the endpoint of A, and then pretend like this is my new origin for B, and go from B, the length of B and the direction of B, from this endpoint, I wind up at the end, after doing this, at A plus B, at the endpoint for A plus B. What other path could I have taken to get to this endpoint, you might ask? Did I have to go A and then B first? Or could I go B and then A? Again, remember, the initial point of the vector doesn't really matter. It's just the length or magnitude and the direction of it. This vector A is the same as this vector A because they both have the same magnitude. They both go up 2 and over and right 1. This goes up 2 and right 1. And they have the same direction. They're both at the same angle with respect to the positive x-axis. So it actually doesn't end up mattering if I go A and then B to get to this point, or B and then A. And that says that the addition of vectors is commutative. So I'll just write this down. This is also equal to vector B plus vector A. It doesn't matter which order you add these vectors in, you'll get to the same destination. So the graphic approach to adding vectors is to draw the first vector, or the second vector actually, because you can do it in either order, but draw the first vector, and then draw the second vector with its initial point at the end point of the first vector. And then where you end up from there is the vector sum. So let me just write all that out in words. Of course, in general, it's easier to just do the algebra of it. Let's turn this back. So, to add vectors geometrically, draw the first vector with initial point at 0, 0. And then draw the second vector with initial point at endpoint of first vector. Vector. And then where, I'll just say this, the endpoint of the second vector is the endpoint of the sum. It's a lot of writing. Okay, I'll leave that up there for a second. So again, to get where we're going, you draw the first vector. In this case, we can draw A or B. And then you put the second vector that you're adding to it, the vector you're adding to it, so that its initial point is at the tail or end point of the first vector. And then your destination, the end point after that, is the end point of the vector sum. And the next video will be about vector addition, or vector subtraction, excuse me.